All right, welcome back to another video. This one hopefully is going to be exciting for you because you can watch probably one of my favorite chemical reactions between silver nitrate and copper, in which we're going to be extracting the silver that way. And it's really cool to watch because the silver ends up showing up on the copper and just kind of coming out of solution basically and showing up on the copper in a really neat like visual way. And I'll do it in time lapse so you can kind of see it that way as well. And yeah, fun reaction. And the cool thing is too that at the very end you get silver as a byproduct, and so, or not as a byproduct, as the product. That's the main product we're after. In fact, actually, speaking of byproduct, another cool thing is the solution is going to go blue because of the byproduct that we're going to get. So let's get into this. So this is going to be a percent yield lab. This is basically taking the concepts of this chapter, and I could have picked 100 chemical reactions because basically this chapter is what chemistry is all about. At least when it comes down to once you get all the basics and groundwork of chemistry done, then when you start going to work, you start mixing chemical reactants to get products, and you need to know what those quantities are. So it's a lot of math, and this is just one example of how you would use math to figure out how much of a product you're going to get, how much of a reactant you'll need. And so these are calculations you'll do. And unfortunately, I'm sorry you guys can't do this experiment yourself, but hopefully it's still just as exciting to watch. And I encourage you to pay attention because I want you to do the calculations as though you were doing the experiment. I want you to feel like you're doing the experiment. So I'm trying to provide that environment here for you so that you can be engaged with this and connected with it. All right, and so this is the percent yield lab. And basically we're going to be getting the percent yield of silver. Let me show you what I have here on my wall, maybe give you a better angle. So step back here. Okay, that equation right there, by the way, is not balanced, so keep that in mind. I'll say that a few times to remind you guys. I'm not trying to leave anything out, you know, like irresponsibly. It's something I want you guys to be able to determine. So I'm giving you a recipe here, but it's not really accurate because it's not balanced. Now this has got to be one of the easiest equations to balance, so hopefully some of you have already figured that out just by looking at it right now. But don't copy that down and think that that's it, because it'll mess up the entire lab. That equation is not balanced. But that is what's going on in this lab. We are taking that first compound, silver nitrate, which is going to be a solution, and then we're going to be mixing that with copper. Cu stands for copper, solid copper, just solid copper, elemental copper. And then what we're going to get is silver solid plus another byproduct is that copper nitrate solution. So let's look at what's going on here. We started out with the silver ion in solution, right? Because when you look at silver nitrate, it's an ion in solution. But on the product side, on the right, we get solid silver. So that's just going to the silver ions are going to come out of solution and become not ions anymore, but neutral. Now, how do they do that? Well, metals, remember, usually lose electrons to become ions. So the reverse happens. They're going to gain electrons in order to be neutral again. And so what's going to be giving those electrons away? It's going to be that copper there, because check it out. That copper is going to start out as solid, which means it's just going to be neutral copper with no charge. But in the end, on the right side of the equation, we have copper in solution. And the only way for that to work is if copper becomes an ion. And in that case, if you look at that formula, you can see there that copper is going to have a very specific charge there. Okay, and so copper is going to be giving silver electrons, basically. That's kind of the story that's going on here. And so the question for this lab is, what is the percent yield of copper? Of silver. What is the percent yield of silver from this chemical reaction? All right, so what is the percent yield of silver from this reaction? And your hypothesis is going to be based on this amount here. It's going to be based on this amount here. So your hypothesis, you know, if you were to make a sentence, would sound something like this, you know, based on, hopefully you reword this sentence to make it your own, but based on the quantities that we are using, and then you'll put those quantities down, we should get theoretically such and such amount of silver. So you're going to calculate your theoretical yield of silver right away before you even do this, get started on this lab. You're going to calculate how much silver you should theoretically get. And then you'll watch part 2 of this video to see how much I actually get. So I'm saving you guys a lot of time here. And then you'll do the calculations to see what's the percent yield, how well did I do using filtration. So you could include that into your hypothesis as well. What's the percent yield of silver using filtration? And this is a redox reaction, by the way. You have oxidation and reduction happening. That's why redox is the abbreviation for reduction and oxidation. And if you remember from last chapter, or chapter 7, I should say, the substance that is losing electrons would be the substance that is oxidized, and the substance that is gaining electron is the substance that's reduced. And I know that sounds weird that you could gain something and be reduced, but the way to remember that, since it is kind of weird, is the mnemonic oil rig. So oxidation is losing, reduction is gaining, and in this case silver is going to be reduced. It's going to be gaining electrons, and copper is going to get oxidized because it's going to be losing electrons. Okay, and so how much silver are we working with? Well, if you look at the bottle I have here, it's 0.5 molar. It's 0.5 molar, which on the bottle it just says, you probably can't see that, right below silver nitrate solution, you'll see in small letters 0.5 molar. That's a concentration. Now they could have given a percent or something like that, but the way they do chemistry, the way they do concentrations in chemistry, is they put capital M for molarity of a solution. And what that means is how many moles of the substance you have in 1,000 milliliters of solution. Now you got to remember that bottle is silver nitrate, but it's mostly water. All solutions are usually mostly water. The substance that is being dissolved in this solution, though, is kind of what you're concerned with, right? So the concentration of a 0.5 molar solution means that you have 0.5 moles of silver nitrate in solution, in 1,000 milliliters of solution specifically. Now, we don't necessarily have 1,000 milliliters of silver nitrate there, right? But that's okay. That doesn't matter. The concentration means that if I had 1,000 milliliters of that solution, I would have 0.5 moles of silver nitrate. So all you got to do is do a simple proportion there, and we're only going to use 250 milliliters of that stuff. And so cross multiply and divide, and basically that's going to be how many moles of silver nitrate should technically have, that we're going to be working with. Now, shouldn't that be directly related to how much silver we're going to get? Absolutely. All of our silver here is going to be coming from the silver nitrate. And so if we have X amount of moles of silver nitrate, that means that we're going to have X amount of moles of silver, right? So there you go. Let me change camera angles here and go ahead and get the chemicals mixed up for you. See if I can do this holding the microphone as well. I pretty much got everything ready to go, so I could just do this quick. Part 2 of the video will be very time consuming for me, but for you guys, you can just watch a quick time lapse and then watch me weigh the silver, okay? But right now, I do already have in this beaker here the 250 milliliters of silver nitrate. I just put the bottle here for decorations, all right? But all the silver nitrate is in this beaker here, and it's almost to the brim. I maybe should have put so much in there, but it's to the brim. But that's good because I need the copper to always be in solution. So I have my copper here, and I need it to always be in solution, so I'm glad it's full. But we have our 250 milliliters of silver nitrate, which remember is a certain amount of moles of silver nitrate, and you need to know that. And I'm about to get all of that out by using copper. Now, this doesn't need heat. It doesn't need any activation energy. What's really cool about this reaction is I can literally just drop this thing in there and it immediately starts reacting. Well, you know, in about 10 seconds or 20 seconds, just enough time for me to get my iPad connected to my tripod here and push record for the next, it probably takes about an hour for it to completely react. Now I need it to completely react, completely react, completely react. I said that 3 times so it'd sink in. This is very important. How do I make sure I completely react with all of that silver nitrate? I better have enough copper, right? So you can see I have some elemental copper here. I've just coiled it up into a little wire so it can rest in there. Now, I didn't want it, it to be stacked. I didn't want the copper to be stacked on copper, so I made a coil like this so that there's plenty of surface area for the reaction to occur. In fact, every 15 minutes or so, I'll come in here and probably just flick the glass and thump it so that the silver that precipitates onto this copper wire will fall off, exposing more copper to react to this solution. But basically, again, I need to have enough copper to react with all of that silver nitrate. And then eventually I will weigh the silver that's produced and we'll have an actual yield there that you can compare to your theoretical yield to eventually get your percent yield, right? Remember that your percent yield is just a fraction of what you theoretically should have got. Now, maybe I can get it all. We'll see. Maybe I can get 100% actual yield or 100% percent yield, and that'd be awesome. So back to the copper though. Again, I needed enough to completely react, but what I did is I'm going to throw in just a little bit extra amount of copper, just a little small piece here that makes sure I have excess copper. So at the end of the day, is it a big deal that we have extra copper in there? No, in fact, that's a good thing because it lets us know that we've reacted with all the silver nitrate. What if I put exactly how much copper would be needed in there and just left it at that? Well, then it would all the copper would react too, but I wouldn't know, like, did I completely react with all the silver nitrate or did I need just a little bit more copper? So you get a little bit of reassurance when you throw in a little bit of extra copper. And so that's another thing I want in your lab report, okay? I want, when you get down to the experiment, in the experiment portion, I want you to write down how much copper we are using in this experiment. I'm not telling you because you can also use stoichiometry to figure that out, all right? All you got to do is start out with how many moles of silver nitrate you have and simply do some conversion factors that will figure out how much copper you should be reacting with. And then just add a little bit extra to that just to say how much we're using. But I want to see that you have the number of what we should be using to completely react. And then just say in your experiment portion that we're using slightly above that, just slightly above that number so that we have excess. All right, so don't forget to balance that equation. I told you I'd say that more than once. That equation's not balanced. Once it's balanced, then you can start doing all your stoichiometry properly. And by the way, guys, if you need help with this lab, feel free to come in my Zooms and ask me then. Hopefully I can help you guys out with that. So let's, do I have my iPad ready? Because I want to make sure I get this reacting right away, but I want to make sure there's any other details that I need to say. Yeah, there is actually. Let me walk through the whole scientific process. So you got the question, which is what is my percent yield, or how high of a percent yield can I get? Make up your own question to reframe it. But essentially, how well can I do in percent yield, in terms of percent yield, through a filtration process or extraction process of silver from silver nitrate using this equation. And our hypothesis is that, your hypothesis is that you'll use a filtration technique and stoichiometry to determine your, number 1, theoretical yield, number 2, actual yield, and number 3, finally, percent yield. And so for the experiment portion, remember, put down your steps, minimize your steps to 3 to 5 steps. And basically, I have 250 milliliters of silver nitrate in a beaker here. That's, remember again, 0.5 molar silver nitrate. We have X number of grams of copper that I want you to figure out that we're submerging in the beaker. We're going to let that sit until the reaction is completely over. And then I'm just going to pour off the solution and I'm going to rinse it so that it's kind of washed a little bit. The silver, I'm going to wash the silver a little bit so it's pure, and then I'm going to let it dry. I'm going to let it sit in this hot shit all day and let it dry, and I'm going to put it on the scale and weigh it. And then once I weigh it, I can do my calculations. And so for your data table, remember there's a few different values you need. Number one, you need to know how many moles of silver nitrate you're working with. Okay, you also need to know how many moles of copper you should use, but convert that to grams of copper too, so that a real person doing this experiment could redo your experiment. So how many grams of copper is that as well? But again, you wouldn't know that until you first know how many moles of copper. You're also going to need to know how many grams of silver you're going to get. You're also going to need to know theoretical yield, actual yield, and percent yield. So those things should be in your data table. Organize that how you choose. And then finally, for your conclusion is basically that percent yield. That's the main calculation that we're after. Once you have your percent yield, you can say how well or how not well I did, right? So you're basically criticizing my experiment, I guess. So that being said, I guess we're good to go. I can go ahead and throw this in there, and then I'll get my iPad set up so that you guys can start watching that. Thanks.